So last time we left over here. Okay, we ran out of time. We went over more hour. I'm just making this hour long, or try to make them short as possible, because, well, you usually don't like long videos. I can go for hours, trust me, because, well, you know, every day I'm doing this for hours. So what we're doing over here, okay, we have our path. We have our two paths basically, where we can walk this turn and where we cannot walk this turn. So let's get this guy moving on our manager, on our game manager. We're going to start with the game manager right now, or actually, since we now have time, let's go and write a proper unit script. So on our managers, or maybe on our units, create folder. Let's call this units, and we're going to call this unit, or let's call it the unit controller. Let's create the proper namespace. And let's start deleting a few crap. Okay, so we want initialization. We want, well, for now, let's go with vector3 target. Let's call this start position. At least for now. We'll see in the future what we're going to do with this. And we're going to need a few more info. So, for example, we're going to need a list with a path info, not path finding, path info, which we should probably get from things the game manager. We wrote something wrong, yeah. Okay, that will be db path info, and that will be your target path. Now we have we need an index, we need our moving t, we need also a rotation t, we need our actual speed, or well, these are just a few stuff. Start position, target position. Okay, if we have initialized our lerp, and if we are actually moving, maybe we should just delete this one and just handle the unit controller from the moving. We need moving over here. And at least for now, this should do. This should do just fine. We're going to create a public node. And we're going to call it node, and we're just going to get a getter in here, and we're going to say return grid base. There's no need to save your grid base. Get node from world position, transform dot position. The fewer variables you have, the fewer memory you get. But of course, this is just pointer, so it won't be that much. Oops. Important. Okay, but here's what we have, and we can do previous node in here. Previous node. Come on. On initialization, we're going to do quite a lot more stuff, but for right now, let's not do anything. So let's add also a public integer action points. Let's go with 20. Let's start with 20. Now on update, we can have an updater, well, you know, an update master that handles all the updates, but for right now, let's only go with a simple update. And in here, we're going to create a few more functions. So in case if we're moving, so if move, if moving, take notice to get the differences, or, you know, maybe write a little bit cleaner. Moving, not movie texture. Okay, moving logic. So if you haven't yet initialized your lerp, and if your path index equals your path count, okay, then that means you are basically on your destination, so you don't want to move. Okay, and then we simply return. Otherwise, we have not any lerp. We need to know our current node we are. We're going to turn it into walkable. Then we're going to start resetting our variables. Rotating. Start position is going to be this transfer position. Target position is going to be your path. Path index. And your target position. Okay. This probably going to make your characters a little bit down to the ground, but we're going to change that later. So for right now, let's go with this one. So we need to calculate the actual distance, because when you're moving diagonally and you're moving, Manhattan, then that means you should be moving the same distance. So we need to find the same speed, not the same distance. Start position with target position. We have our distance, and our speed base should probably be, well, we can have if we are running, if we're walking, but let's do this later. So speed actual should be your walk speed. Let's add it in here for now. We're going to create dedicated scripts for all of this to hold all this stuff. Walk speed, let's go with 2. Walk speed subdivided by your distance. Okay, and we say we have initialized a lerp. So if we had a lerp, then what we do, time.delta time multiplied by speed actual. Obviously, if move t is greater than 1, then move t will start as 1. We're going to make our init lerp false, and we're going to create a function that removes our AP. We're going to do this in the future. So if path index is lower than our path.count, minus 1 of course, and path index plus. Otherwise, simply stop moving. Okay, simple enough. And then of course vector 3, new position, and we're going to do a lerp. Oops. Start position, target position, all that based on our movement t, and simply set transform.position equals new position. So what I'm doing over here with a node is basically I don't save any node. Every time I want to check the node for this guy, I'm just going to be checking this node. Okay, I'm not saving it anywhere else. I'm just using, and if I'm going somewhere, I'm saying node is walkable to true. We should probably also change, we should also add our rotations to this. So we have our rotation t, time.delta time multiplied by, let's go over here, maybe add public float, rotation speed. Let's go with something fast, doesn't matter. Rotation doesn't play much of I think, yeah, let's fix it. Doesn't play that much of a difference. Rotation speed, okay, and we can say we need our look direction, going to be our target position minus our start position, and then our y is going to be 0, and of course if look direction equals vector 3.0, then your look direction is going to be your own transform.forward. Then we're creating a rotation or a quaternion, however you like it. Oops. Quaternion dot look rotation look direction. Okay, normal stuff. We're not doing something wild, we're just creating rotations. Let's do it let, it's better I guess. From our own transform dot rotation, then to our target rotation, and then we pass rotate t. Since we don't have multiple units, we don't need to worry about setting the node to non-walkable when we stop, but we're going to take that, we're going to do this in the future. And let's see, actually I think we could, let me see, have our path index. Yeah, let's add the remove AP in here. And I'm just going to do remove AP. And in here I'm going to say path info P. And we have a current action points, or our action points. So we're going to just do the action points we have into our path info, and we're going to say node, oops, is walkable to be false. So when we are removing our AP, we only need to pass our path with path index. Now the difference with the old and other turn-based systems, okay, is that even if we are moving through our grid, I'm not going to hit play right now, we can't stop in any tile. So if there is an interruption or if there is something else, it's not like on XCOM that you select a position, a target position, and go over there, and even if there is an overwatch, they just shoot on your target. Okay, if there is an interruption and somebody shoots you, your player can actually stop over there, and then you can play and keep playing your other, well, you know, you can continue your own turn. So over here basically we can do a lot more checks in the future that has to do with enemy AI and stuff like that, and interruption checks and all nice stuff. So we have all this, and let's see, we have all of this. Now we need to hook everything into you know, our game manager. But before we do that, let's create let's leave the init for now. We're going to add animators and stuff like that in here in the future. Let's create a function that is basically going to populate this path. Having logic, close this, and I'm going to say public void add path, and we need to pass a path info P, and then we're going to set the path index to 1, not 0, because 0 is our own target position and we don't want to lerp on our own target position, and then our path is going to be our own P. So we're going to be calling this on our game manager, and we're going to go in here. We have all our paths. Okay, we find our, let's create visualizations. and let's call this Pathfinder. I need and region. Okay, we have all Pathfinder in here, and before we do that, we're going to say if has path. Actually, let's see. Yeah, if we have a path and path info not equals null, it might be look a little bit redundant, but it doesn't matter. Take this over here, and we're going to say if moving, or maybe, yeah, let's write the unit controller first. Instead of current unit, I'm going to say unit controller, and I'm then going to also name it current unit. Unit controller, that's the proper way. And we should probably get an error. No, we're not getting an error because we still access the transform. And we can say over here if current unit not equals null, no, if current unit moving, return. Okay, and probably get all these two and add it in here. So basically this is not going to let any of the other logic to run when your current unit is moving. And in here we can say if input dot get mouse button 0. We should probably add in the future if we are not over a UI element or something like that, and we're not moving, then we can say current unit dot add path, and we have our path blue that we can add, or no, this is the line header. We want this path info add path. Okay, we have our path info, and we probably just say current unit dot moving, or maybe yet let's add it in here, add path moving to be true. Okay, let's save, and for the most part it should be fine, I guess. We'll see. We can change a little bit stuff though. On our Pathfinder, for example, we have our unit node. We can just do current unit dot node. Okay, so it always get the correct node, and we also don't need the unit node anymore because we can get it from the current unit. Let's save. Let's see where else we are using it, which is over here. So we don't need this anymore, and we also don't need this one. And the only check we can do is if current unit is null, then simply return. Okay, close this. Let's see if this is going to play without any problems. If we hit play, we have an error. Let's see what it is. We forgot to assign the current unit. We have our unit, and then we can place it. We haven't assigned unit controller. We have our unit controller now. Grid base, unit, and let's hit play. Okay, we have our unit, we have our path. We're going to fix also the red one. And if I click play, if I right click, we go towards the path we want to go. Of course, we're not going to go over the red parts. And you can see now that I can still move, that I'm getting blue lines, but in my unit, I don't have any action points, or I only have 2 action points. So the reason for this is because we forgot we are basically using these action points. So deleting these action points, oops, come on. We're going to get a few errors, and we're simply going to change the action points from here to current unit dot action points. And since we are also here, let's change the if red info is null, we're going to do an else, and red info dot trans, no, this is the list. Yeah, this is the list. We want this actually, or actually no, we want this. Path red dot game object set active false, and in here path red set active to true. So this is going to enable and disable your red line renderer. Now, yeah, this will work probably. Let's hit play. Okay, notice the action points. I think the red lines don't work. Yeah, because we are always adding one, so we can say if let's fix it right now actually. So this will probably never going to be null. So this is redundant, but we can say if count is greater than, instead of 0, let's go greater than 1. Set active, else this should be false. Let's hit play. Okay, now it works properly. So I'm going to move, and you can see now that I'm updating the position. I only have 2 action points, so that means I should yeah, we probably have a problem with the diagonal movement, I guess, because the first one you can see that I can always move, and I probably shouldn't be able to move with diagonally with only 2 action points. But anyway, this will do. You can see that now that we cannot move anymore for this turn, unless of course we add more action points, and we are back at it again. So this is basically just assigning action points. Now let's close this. Let's go to our callback in here. We should probably fix this one. Get path direction from our current node. Yeah, the current node is actually wrong. This one is probably the issue, and it should be the starting node we need. Target position, current unit, transfer position. So let's take this instead of current node, current unit dot node. Let's create no, let's not yet, just yet. Let's close this. What I wanted to do, let's see if now this is going to work. If not, let's move a little bit. We have our unit. Let's set this to 2. Oops, I probably should have done it before I pressed that. Okay, now it works properly. We cannot move diagonally, but if I want to move on a node that is going to only take 2 points, then I can do it just fine. Okay, pretty well, it's pretty simple, as you can see. So let's create one more unit. Let's leave him there, and let's go fix the units. So we're going to just remove this, delete it, and we're going to assign it on our unit controllers. Basically, we're going to assign it on init, and for right now, let's also add a start or actually we cannot add start because the grid is created on start, so we cannot add a start. And let's create an integer x, y, z. It's probably a bad idea to add x1, z, so let's go x1, well, at least for now, x2, x3. So grid base singleton x1, x2, oops, yeah, I'm going to remove x2. This will probably be z1. I'm just going to set this to 0. This is going to be z1, and our current transform position is going to be whatever we have from here. However, we still need to add this somewhere. So in my game manager, I'm going to add a public list of unit controllers, and I'm going to say units, and let's initialize it. Oops. So on start, now we can create a start, void start, and in here we can say, actually maybe start is indeed a bad idea. So instead of adding it on this start, maybe we can do it on grid base, I guess. Well, anyway, let's just manually add them in this list in here, since we're going to be creating them in the future. So let's just manually add them in here. Or an int, I'm just going to do for units dot count units I dot init. Okay, pretty clear. So this is going to actually initialize your units, and since we're also here, let's also create an animator. Oops, not animated, animator, and we can say anim equals get component children animator. But for right now we won't need this, so let's just comment it out in here. Let's go into our previous scene. On our grid base, let's add our units. We can still keep the current unit, doesn't matter. Okay, and we're over here, and we can say let's go with 5 and 6, and maybe 6. This one is also 6, and maybe this one is 4. Okay, and what we also forgot, well, actually, let's just see what we forgot. I'm going to click play, and everyone is right up next to each other. Okay, and as you can see, we forgot to also update the node we are in, that it's not walkable anymore. So we're going to do unit. Let's set the node. Let's see, on our nodes, let's make this, we have is walkable, it's true. Let's maybe do a get set, which is get return value, or is it walkable, and set. We should probably store, yeah, let's have it in here, I guess. Debug material, public material, unwalkable material. Actually, this is going to be a bad idea, but anyway. and we're going to say if world object is not null, then world object get component. Now this is horrible, I'm just doing it for debugging purposes. You probably don't want to do it like this. Get component in children renderer material, and the material should be, actually let's do a grid base, grid equals grid base singleton, be if your value is true, then should be grid dot debug material, otherwise should be grid dot unwalkable material. Okay, and then whatever this does is going to do is walkable to be the value you are passing. Okay, so this will also change the material on your renderer depending on what you're doing. And we go on our art, materials, debug material. Let's just use this one, who cares. We have our grid base, unwalkable material, use red, and on our unit controller over here we can say node is walkable, false. Okay, so the first node we are in is not going to be walkable, the first one we're moving, and I'm going to change this to maybe 8 instead of 4, so they have a little bit of room. So let's see what yeah, we have a Stack Overflow. So let's write this a little bit better. Yeah, I don't really care for this, so let's change this to over here. Let's set this to true, and let's make public void change node status, and we can say don't want any of this. I think we might not even assign the world object. We're going to say bool value over here, and is walkable to be the same one as your value. Oops. Let's see where we assign this now, and is walkable, and change node status to true. Do we assign the world object? We are not assigning the world object, so this will not change anything, to true. So this is going to be world object to be the new game object. Let's see where else we change this. Is walkable, final references, is walkable value over here, and here. Okay, so node is change node status false, and the last one should be over here to true. Okay, let's see what this is going to do. So you see that the first one we are in, it's actually non-walkable node, and when we are moving you can see that for as much as we are passing, so at least for that frame we are over that node, that the other one is yeah, it's basically unwalkable. And if I go into my game manager and select my other unit, I will basically be able to move my other unit now. Okay, let's make it so that we can select units. So instead of assigning, drag and dropping our units, we're simply going to select them. So on update, whenever we click, we're going to create a new function, and we're going to say, come on. We're going to return, we're going to look for a unit controller, and we're going to say node has unit. We're going to pass a node on top of this, and we can say for all the units we have, units.count if, well, we can do a little bit of a brute force in here, so we can say units, or maybe yet, let's do node by node. So we have our node, the node of the unit, so those probably is going to be UN, and we have our target node, so we can just compare and say if un.x equals n.x and un.y equals n.y and un.z equals n.z, then return your units I, okay, otherwise return null. So basically this is going to compare all the nodes on your units and see see if there is anyone. Depending on if you're ever going to have more units than nodes, which you're probably never going to have that many. Okay, we basically just don't want to store a lot of information on all the nodes, because, you know, all that takes memory, instead of just comparing this in a single frame. So yeah, it's probably best to do it this way. So on update, we're going to say if we are actually pressing down the button, we're going to say we're going to be looking for a node. Unit controller has unit. It's going to say node has unit, our current node, and if has unit is null, then add it in here, and else, actually, yeah, let's see, if he has a unit, we're going to simply change unit. So we're going to say current unit will be the new has unit. Okay, and we can add over here and current unit is not equals null. So this will either change our current unit, walk, or do nothing. Let's go out and test it. We have our grid base. I'm going to deselect, I'm going to remove this one. Okay, and when we click play, you can see that the path doesn't move. When I select somebody, well, that didn't work. And I think that didn't work because we have, we have this one. So we should simply delete this and move this one further down in here and say if current unit equals null, return, and we should probably say if yeah, if current unit is not null, it's not null, and if current unit dot moving, then return. Let's see if this is going to work. We got an error. Oh. We have these two because, you know, the player might actually click when you are moving, so that might give us a few problems. So let's click play right now. I'm selecting, and it doesn't do anything. Let's see why. And let's debug it. Oh, because we have the hash path and path info, so we going to remove this and put it in here. We should probably delete one of these here, and no, not here, and here. Okay, because we were never going in there if we didn't have a path, and of course if you don't have a unit you cannot have a path, so that means you cannot move. Simple, very simple stuff. Let's see. Okay, and now we can select units that they can also work. Let's create an animator since we are over here. Let's create a folder, animator controller, create animator controller. Let's call this units. Let's create some parameters. For right now we're going to go with only vertical, and in the future we're going to do a lot more stuff. Let's go with locomotion, locomotion normal. Open it up. One directional will be enough for now. Locomotion, and we can do idle, unarmed, and unarmed walk for now. And actually this idle might not even be the best one. Anyway, we'll see. And okay, we have also an animator. Let's assign it on our units. Dropping it in here, you'll see it will, oh, actually I don't want it there, I want it on my boxman. I already have an animator in here and in here. So on the script this will go, let's get this one on, and where we are actually moving over here we can say, or let's go do it on the end. We can say anim set float vertical 1 0 1 time dot delta time. Maybe if we actually remove that and inside update we can do it in here. So here will be this, and this will be 0.1. I think it's too little, so either 0.2, maybe this one 0.2 and this one 0.4. Let's see. Okay, of course he's moving way too fast, and of course we also have enabled root motion, and the animations have root motion. So anim dot apply root motion be false, and I think we have something else. Yeah, we also need to change the speed. So let's change the speed to maybe 0.5. We'll see. And yeah, let's not do it in here. Let's change it also in the inspector. here and here, and actually 0.5 should be, maybe it was the speed from the root motion that was, yeah, that was the problem. So 2 should be more than enough. So let's bring this one up in here. Okay, way better. So we also now have animations and stuff like that. Let's add something else right now. Let's add a new game object. Let's add this is a level manager. Let's call it that. And in here I'm going to go scripts, managers, create level manager, namespace, say turn-based, let's delete all of this, and here's what a nice trick we can do. I'm going to get all my transforms, or a list of transforms that I want to have, transform, and I'm going to call this obstacles. Okay, so here's what I'm going to do. I'm going to do public void load obstacles, and before we actually write something in here, let's make this also a singleton. So public static level manager singleton void awake singleton should be this. Again, as I said, if you are afraid that you might have more than one, then play it more safe. Let's get our grid, not a guild, grid base singleton, and then for each obstacle we have, or for all our obstacles, count. Let's get our target position, our position. You're going to see what I'm going to do right now, but I'm going to tell you why this is not going to work for the final game. Okay, we have our positions, obstacle positions, and what we need right now is basically get on our grid. We'll get a node from our grid, and we can say grid get node from wall position, pass our node, and then say node is walkable will be false. Okay, nope, we change this one. We want to change node status to false. So after we have created our level, which I've closed my grid base for some reason, let's go to the grid, grid base. We can say we have initializer game manager. We have yet before we need, we can say level manager singleton dot load obstacles. So, and on our grid base, well, let's just put this one up in here, Pathfinder master, grid base, level manager. Okay, we don't want the other ones. Close this, and level manager. Again, you can have them on the same, well, the level manager, you can load them through with each level. Okay, so we have a list in here. Now, if I'm going to create a few boxes, I'm going to make sure they are all on, I'm only concerned about the Y. I don't really care about what is the X and the Z. My only concern is that the Y is at 0. And I'm going to add positive values. Maybe this one will be something else. Instead of 26, let's go with 2. You can say I'm just adding random values, so I don't really care. Maybe something like this. I just want also positive values. 26 might be enough, it might be a lot. Okay, these are just random positions, so I'm going to go on my level manager, lock, add them in here, and here's what's going to happen when I click play, and if we don't get an error, of course. And nothing happened. Beautifully. Or did it happen and maybe we didn't notice? See? Yeah, let's get all of this and maybe lower the scale to half or whatever. Let's leave this to 2. And oops. Oh, this was the level manager, yeah. It wouldn't work anyway. 0.5 to 0.5. Hit play. Okay, so basically what we're getting all the positions from each one of these objects, or these, you know, well, the columns or whatever you want to call them. And we're basically updating the grid without having to worry about changing or sampling each one of these nodes. We're just seeing beforehand where obstacles could be, and then we're updating the pathfinder, or well, our grid through there. Okay, this is vastly different from what we were doing before, because this is much more lighter. The only problem is that if you have a bigger object, for example, one of your cubes are like this, that can populate a lot more spaces, only the center one is going to happen. And it's something we're going to fix in the next video, not in this one, because we are close to an hour. So the last thing we're going to do, let's also delete this one. The last thing we're going to do is we're actually going to, let's make a camera manager. So I'm going to create an empty game object. I'm going to reset its rotation, reset everything, and then drop the main camera inside. Actually, reset the position of the main camera, change this to local, drag this back somewhere like this, and drop it in here. Rename this to camera manager. You can also add a pivot if you want to, it shouldn't matter. We have our camera, let's quickly write a new script that's going to handle our camera. And I'm just going to make this one in here, let's say camera, create new script, camera manager, we should probably make this also a singleton, but I don't think we're going to be accessing this camera a lot, so you know. So we want to see, let me think. We can have also edge movement, but let's just only use positioning, I guess. We shouldn't really care about anything else. So on update, float horizontal, we're just going to use our keyboard, get axis horizontal, float vertical, input get axis vertical, and then we can simply say if horizontal is not equals, well, actually we're going to start with target position, and if horizontal is not equal 0, then target position should be horizontal multiplied by our transform.right, and if vertical is not equal 0, should be target position plus vertical multiplied by our transform dot forward. Okay, we can clamp this into, you know, to be on our grid, but for right now we probably don't really care. And let's see, and then let's do transform dot position sync plus. I don't know why I'm saying sync plus, but anyway, target position. Okay, let's see if this is going to work. It will probably work, but you can never be sure. And yeah, we probably need to also apply speed, public float speed. Let's go with 0.1. Okay, so it's a scale vector. Something didn't saved. And here, let's hit play. And we got an error because because I deleted a list, an object without removing it from the list in here, this one. Okay, and we can even move with the camera right now. The speed needs a little bit of adjustment. Let's go with 0.9 and maybe 0.8. Yeah, 0.8 is okay. And since we have a little bit of time, let's also add rotation to our camera. Okay, and it's going to be the last thing we add into this one. So on our camera manager, inside update, let's encapsulate all of this into a single one. Movement, drop this in here. We can actually create a startup where, you know, make the camera jump when we first start. So we're also going to set rotation bool. We either want to rotate left, so that will be input get key code. I'm just starting with, you know, the key codes, but you should probably change this as well. Input get key code dot E, capital E. And if rotate left or rotate right, okay, we have a value which our rotate speed. We probably should make this speed. Let's go with maybe 5. We'll see. We probably need to change that. Let's also change this. Well, I'm basically changing this for you. So if you're watching a newer video, so you know what value I'm actually using, you don't have to update this one. You only have to worry about what you do in the inspector. But you know, things happen. And if we rotate left, then your value is going to be its negative position, its negative value, and then you need to create a new Euler from your own local Euler angles, and Euler.y plus your value, and then your local Euler angles will be your target, your Euler. And take this, drop it in here, and since we are also here, let's just do it. Let's create an initialization, public void init, and let's also make the camera manager a singleton. Public static camera manager void awake. It's going to be this. So finally, when we're initializing, let's make our camera maybe jump to the center. Yeah, I guess. Or better yet, let's just do whatever. Grid. And do. Let's just do it like this. Target position, grid base, singleton, get wall, no, yeah, get wall coordinates from node, and let's just go with maybe 15. Of course, if you don't have these nodes, okay, if your grid is lower than 15, you're going to get an error over here, but yeah. Target position, and on our grid base, after we have initialized, we can simply do camera manager singleton.init as well. So let's see if this all of this work. Hit play, and you can see that our camera jumps into another node, and we are inside the grid right now. And Q and E works just fine, and we can move, we can select, we can move our units. If I select somebody else, I can also work with the other guy. And if somebody is moving, of course you cannot move. And if you don't have any action points, you cannot move also. This happens because we are pressing the keys. But anyway, we're just going to fix that in the next video along with everything else. So you know what to do. Like, subscribe if you like to see more, then consider supporting me on Patreon, so you know I can continue and keep making all of this. You also get additional rewards depending on the pledge you are in. And the other way you can support me is of course through Gumroad, where you can get a few projects, including this one, well, when it's ready. And yeah, everything goes back into making all this nice stuff. So I'll see you on the next one.